and welcome to another level 3 paper classroom 5-minute video, another definitions video. In this one we're going to talk about heat transfer. So what is heat transfer? Heat transfer is moving heat from a source to a receptor. So transfer of thermal energy resulting from a temperature difference is one of the usual definitions of heat transfer. Not always the case, but for these first two it is. There are three mechanisms of heat transfer. There is conduction, there is convection, and there is radiation. So we're just going to talk about simply describing these three methods of heat transfer. Conduction is the most obvious one. You take a metal bar, you heat it with example for a Bunsen burner, as you see there, and what happens? You put energy into the molecules at the end of that bar. All molecules vibrate. Putting energy in makes them vibrate faster. By vibrating faster, they will then hit an adjacent molecule and they will make that one vibrate. That will move along and that will make another one vibrate. So the molecules stay exactly where they are, or the atoms stay exactly where they are. They just vibrate faster and faster, knock into an adjacent molecule and make that one move faster and faster, and on it will go. And as you see with that bar there, you've started off here where the energy is very high because this is where you're putting all the heat in, and each molecule is transferring some of its energy via vibration mechanism to the next one and the next one and the next one. It's got to about there. If we keep heating it up, then it will slowly move along, and if you're holding that bar, you'll suddenly scream and let go and drop it because it'll be very hot. So that's the conduction mechanism. It's a flow of heat, and it transfers energy between adjacent molecules, but there's no mixing. The molecules stay exactly where they are, they just vibrate faster and faster. So that's conduction. If we look at convection now, then the common example of convection is something like this. We take a beaker, we may put a crystal of potassium permanganate at the bottom, we'd put a Bunsen burner underneath the potassium permanganate, and what we will see is the potassium permanganate dissolving. It will cause the water to expand because it's got more energy. Because it's expanded, it will be less dense. Because it's less dense, it will rise to the surface. Once it's risen to the surface, it's not left a space here. Water will be sucked in to fill that space. That will cause the water at the top here to flow that way and then be pulled down, and so you've got this circulating mechanism going on. So that's really convection. It's the way heat is transferred in liquids and gases rather than solids like we saw earlier. Molecules carry heat from an area of high energy to an area of low energy. At that point, they give up the heat, and then having given up the heat, they then return to the source to gather more heat. And there's a really good video here on YouTube for those learners of mine who use Moodle. There's a link to this website, and there's a video showing these convection currents using sort of food dyes. It's really good. I would recommend that you have a look at this. Finally, we need to talk about radiation. Whereas conduction and convection need solids or liquids or gases, particles that energy is either moved along with or transferred to, in radiation it's not so. In radiation, these are electromagnetic waves, for example infrared rays. So you've got the sun generating all the infrared radiation. It ships the radiation through space where there are no particles, and the Earth absorbs the radiation and converts it into heat. So summary, quick 3 points just to summarise what we've discussed. Conduction. It's all about particles bumping into each other but not really changing position, therefore not mixing. Convection This is where particles do move around and they mix and they transfer energy. So they absorb energy and then they let go of the energy. And finally, radiation. It doesn't use particles, but it uses electromagnetic waves. Thank you for listening to this short presentation, and please feel free to follow us on any of this social media. Thank you.